So we are going to make assembly of this chain, which is the practice test for the SolidWorks CSWA exam, the certification exam. These are the sample files. So first we have to add this link one. Okay. So insert it. You must be in the assembly environment. Open it in the assembly, and when you click and open it, it will be attached with the mouse. And when you drag your mouse, you can uh, drag this component with it. So first I am going to go to here visibility of, and I am going to check these origin, the view coordinate system and the view origin. So it will show the origin of this assembly environment here, and it will also show the origin of the component. So basically we have to align this origin of the component with the origin of the assembly. So here you can see our model is lying like that. We have to rotate it around the x-axis. So here you can see we have the x-axis. So we have to rotate our model around the x-axis. So this origin which is showing here vertically on the other side, it must be on the top. So we can click here on the x-axis, and you can see here, no, our origin is on the top. So we have to align this origin with the origin of the assembly. So when you rotate the model around the x-axis, it will be like that. Now move your mouse near to this origin, so it will snap this origin like that. So if you are here, it's not snapping it, but when you move your mouse, this cursor, the symbol showing with the component, which is telling we are uh, inserting a component in the assembly. Okay, so move your mouse near to this origin like that, and it will automatically snap the origin of the object or the model. So then you left click to place it. Left click and place it. So now the origin of the assembly environment and the origin of the component is attached with each other. So that is the basic step for doing this test for this SolidWorks certification test. When you given this assembly, you have to make sure the first component which are you are adding, it must align uh, with the origin of the assembly. Okay. So here you can see we have the front, top, right plane for this assembly, and we also have the origin, and we also have the origin, the local origin and front top plane for this component. We can say that these are the local planes and origins. So the origin of the component must align, or it must be like coincident with the origin of the assembly environment. Okay, next we are going to add the other component. So in, and going to place it like that, and place it, and then made. So we are going to add the made between this surface and this surface. So select this surface and this whole, this surface, and it will add automatically a concentric made between them and check mark. So it is added. Now you can see we can move it up and down. And next I am going to select this surface, and I am going to fix it with this top surface. So it will add a coincident made between them. The same way we make the relation in the sketch. Okay. Now for the next component, I am going to select this link, and I am going to place it here. So this link, it is attached with this surface. So it is attached here. So made, select this whole, this surface and this surface, and when we want a concentric relation between them, so automatically a concentric relation is added here, check mark, and then select this surface and add a relation which is coincident between them. So we have this between this link. Okay. Next we needed to add a angular relation between these two links, and the angle is between this surface and this surface, and it will add a coincident relation between them. But what we want a angle between them. So click here on this angle. Here you can see we can define the angular dimension between these two surfaces. So select it, and this is activated, and here we want an angle of 150. So type 150, and if you see the model is rotated in that way, that means its direction is not correct. So we can use this flip dimension and this made alignment. These two things, we can align it in a way that we have the correct angle between these two. Okay, so first I am going to click here on the flip dimension. So if I click here, it's moving downward. That means the flip dimension is not working for us. Now click here on this mate element, and it is this time this is activated. We have to select this one, and here you can see the angle is correct, and we define the correct angle of 150 between these two surfaces. And if it's not, if it's in the other way, then you can check this flip dimension tool like that. So now we have the angle and check mark, and the next component we are going to add is this pin. So place the pin here and add the mate relation between them. So this surface and this surface, we want them. So this surface and this surface, we want them have a concentric relation between them, and then select this top surface and this surface to have a coincident relation between them. Okay. Next, again component and add a link one, place it here. So the direction is correct for us. Add a pin and place a pin here. Okay. Then made, select this hole and this hole, the and add a concentric relation between them, check mark, and then select this surface and rotate the model and make sure you select this side. So these two surfaces of these two components are coincident between them. So it's coincident, click here on this check mark, next select this component and this component, these surfaces of this component then have a concentric relation between them and check mark. Now select this surface and have a coincident relation between them. Okay, next we have to define the angle between this surface, select this surface and this top surface. We have to define an angular dimension between them. So click here on this angle, and so we add the angular offset between them. So for this one, we have 45. So now you can see it's move in that direction. We have to use again this flip dimension and the mate align tools to find the correct direction. So I am going to uncheck this flip dimension. So it's moving in that way. Now click here on this one, align, and it's that way. So if I click flip here, it's going on the other side, but we want it on the opposite side here. So at this point, we have an angular dimension between them, an angle of 45 from between this surface and this surface. So here you can see it's basically 45. Okay. So next again add a component, and we are going to select the link to and place it here. And the same way next procedure, add a mate between this circular surface and this circular surface and select this one. And now we selected this top surfaces, so we have to rotate the model so we can select the surface which is aligned with this surface. So this one, and it will automatically snap with the coincident relation. SolidWorks know that we want to add a coincident relation between them, and at this point we have to add an angular dimension between this surface and this surface. So for this angle, we have to define 130. So activate the angle and here place it 130. And if you make it isometric, and we can see this direction is correct. And if it's not, we can use this flip and this alignment to define the correct alignment. So this point it's good, 130 is good, check mark, and now we needed to define the pins. So pin 2 at this surface, and I'm going to also add the pin. We are going to put it here. So now simple the same steps we are going to define. So select this and select this surface. So that now select this surface and this surface to add a coincident relation between them, and select this and this surface and add a concentric relation between them, then this top surface and this surface to define the coincident relation between them. So at this point, the assembly is complete. We can hide this origin if you want. And here I am going to change the units to millimeter because we want to calculate the mass. So go to the fluid, and here we are going to use the mass properties because we want to find the center of mass. So here you can see the values of the center of mass, and if you see it in the given option, you can see it's near to the option one. You may have a little bit difference, but this difference is accepted. So in the given PDF for the sample test, for the X value, it's given 85.51 and we achieve 85.53. So it's near to that. Maybe some I'm using the older version file that way it's just little bit difference. For the Z value, we don't have any difference. For the Y value, we have in the drawing, it's given in the file, it's given Y minus 10.03, but we got Y minus 10.04. So this difference is accepted for the SolidWorks test. So it's correct. The center of mass is correct. So the most important thing when you are doing the exam for the SolidWorks certificate and you are given a assembly and the components are given, the first component you add its matter. The origin of that component is matter. So with respect to the origin, the center of mass is calculated. So that's why you have to make sure that the origin of the first component which you are adding in the assembly environment must be aligned with the origin of the assembly. So that's the important thing. The rest of the things, if you are doing the SolidWorks test and you are watching this video, you know about the how we add the mates. So most important thing is the origin. You have to keep the origin aligned with the component of the which component you are adding. So in the exam, you are given some files, some components, and you have to make the assembly. So the center of mass depends on the first component. When you edit it in the assembly, make sure its center must be aligned with the center of the origin of the assembly. So here you have to activate this view coordinate system and the view origin. So you have activated the origin of the component and the origin of the assembly. So when you are inserting the component, this must uh, align with the origin of the assembly. I repeated that thing many times, so because that's the most important thing when you are doing this tutorial or when you are doing in the exam. So thank you so much. So if you did not subscribe my channel, please subscribe it because I have to put some effort to make this tutorial. So if you subscribe it, it will really support me. Thank you so much.